Gravity is a lot weirder than you might think. I mean, all mass has it. In the same way that my face was just pulled to the ground was actually slightly pulled up to my face. But this begs the question, how is mass able to pull on each other from such huge distances without touching each other or exchanging any energy at all? Well, there are four forces in the universe that can do this. There's gravity, electromagnetism, the strong force, and the weak force. But there's actually something fundamentally different about gravity. You see, gravity doesn't actually exist. If there's a force applied to you making you accelerate, you're going to feel a push or a pull. But if you're in a free fall, just accelerating due to gravity, you don't feel anything. You feel like you're floating. So gravity actually can't be a force, because it can't be really making things accelerate. What gravity actually is just a warping of space and time. Now that phrase has been thrown around quite a lot, and maybe you've seen a model like this, which shows how mass can make things move. But if you think about it, the model's kind of flawed, because really the only reason the ball rolls towards the mass in the center is because it's rolling downhill in the model. So let's see if we can find an even simpler way to put it. So if I'm floating through space without any constraints or anything to help me change my direction, I'll probably be a little freaked out, but I'll also be moving at a constant velocity, and I'll feel weightless. So what you can do to make it seem like I'm falling towards a planet is actually move the space around me, so I can still feel weightless while I'm falling, and then seem like I'm accelerating. So we wouldn't actually notice any of that space bending. It'd be like if you were on a piece of paper. No matter which way the paper would bend or twist, from your perspective, everything would kind of stay the same. It'd also be like if you were to walk around the world. From your perspective, it would seem like you're walking in a straight line, but from mine, floating in space, you'd just be walking in circles. Your definition of what's straight just depends on your perspective. Well, that explains how an object already moving can change its direction. But what about something that's completely still? If I just let go of this, it'll start accelerating. And if there really is no acceleration, how can you get an object that isn't moving to start moving? Well, actually, the clock is moving. It's moving through time. So when I'm holding the clock, it isn't moving at all up or down in space, but it is moving forward through time, at least until I let go, and then it starts moving faster and faster towards the ground. But remember, while the clock's in free fall, it doesn't feel like it's accelerating or changing its direction. And this is because the clock isn't actually changing its own direction. Space and time are just bending around it, turning what was before its movement through time into movement through space. While from our undistorted perspective, it just looks like it's accelerating. This stuff can be pretty difficult to visualize, especially when there's no 3D examples of space warping that I can show you. And this is because, well, it's really beyond us. If you have our 3D world warping in a fourth direction with the fifth direction of time, then it's pretty crazy. These are directions that we can't comprehend. That's why all my examples of space moving have had to be 2D or 1D. It's pretty crazy that something so normal can actually be the result of warping space and time. And it actually gets even weirder, because in the same way that there's a speed of light, there's also a speed of gravity. If the sun were to disappear right now, we wouldn't immediately go flying off into space. Instead, we would actually keep orbiting around nothing for an extra 8 minutes, which is the same amount of time it would take for the last bit of light to reach the Earth. It's kind of like the surface of a pool. The bends and shifts on the surface of space-time actually take time to get to the other side. Except for in this situation, the bends are moving at the speed of light. You can actually create waves of gravity by taking something really, really heavy and moving it really, really fast. And even though light is massless, if something's heavy enough, you can actually shift the path that it takes. Now, knowing this stuff probably won't help you in your everyday life, but it is fascinating to realize that there are these higher dimensions that we're constantly interacting with, making everything fall and everything move. And I think that's kind of the point of science, and even life, to figure out what the bigger things are. that are invisible to us.